Picture a car moving down a highway. It weighs about as much as a small elephant, and it is carrying that weight at speed. Now you press one soft pedal with one foot. A second later, the whole machine slows and stops. Your leg did not do that. Something quiet and clever sits between your foot and the road, multiplying the gentle push you make into a force strong enough to grip 4 spinning wheels at once. Here is the trouble. A spinning wheel carries enormous energy, and your leg is weak by comparison. Push as hard as you like, bare muscle cannot clamp a wheel turning hundreds of times a minute. The braking system has one job. It must take the small, steady force of your foot and turn it into a much larger force at every wheel, then deliver that force instantly, evenly, and in the same way every single time you press down. It begins under your foot. The brake pedal is a simple lever, hinged near the top. When you press the bottom, the short end on the other side pushes back with more force than you gave it. That is the first trick. A lever trades distance for strength. Your foot travels a long way. The far end moves only a little, but it moves hard. This stronger push now has somewhere to go, straight into a sealed cylinder waiting behind it. The lever drives a piston into a narrow tube called the master cylinder. The tube is full of oily liquid, sealed tight with no air inside. As the piston slides forward, it does not compress the liquid. It cannot. Instead, it shoves the whole column of liquid ahead of it. Like pushing a finger into a completely full straw. The push you made at the pedal is now a push on a trapped fluid, primed and ready to travel. This liquid is the secret. Brake fluid is nearly impossible to squeeze. Squash a sponge and it shrinks. Squash this fluid and almost nothing happens. So when you press one end, the pressure is not absorbed or lost. It spreads through every drop at once, in every direction, with equal strength. A push here becomes a push everywhere. The fluid behaves like a solid steel rod, yet it can bend around corners and flow down 4 separate paths. From the master cylinder, thin metal tubes branch out and run to all 4 wheels. These are the brake lines. The pressure you created races down each one at the speed of sound through liquid, far faster than you can blink. Because the fluid is sealed and full, the instant you press the pedal, every wheel feels it together. There is no slack, no delay, no waiting. 1 foot, 4 wheels, the same command arriving at the same moment. Now the real magic. At each wheel, the fluid meets a piston far wider than the small one back at the pedal. Pressure pushing on a bigger area makes a bigger force. This is Pascal's principle. Press a thin piston gently, and a fat piston on the other end pushes back hard. The system trades a long, soft pedal stroke for a short, ferocious squeeze. Your modest foot, multiplied twice over, now commands thousands of pounds of clamping force. That wide piston lives inside a clamp called the caliper. It straddles a shining metal disc, the rotor, which spins with the wheel. When the fluid arrives under pressure, the piston pushes outward and the caliper squeezes shut, like a hand closing around a spinning plate. But the piston does not touch the disc directly. Between them sits a tougher part, designed to take the punishment and grip the disc without melting away in an instant. Those are the brake pads, 2 blocks of hard, heat-loving material that press against both faces of the rotor. As the caliper clamps, the pads bite down on the spinning disc and hold on. The wheel wants to keep turning. The pads refuse to let it slide freely. They grab the surface and drag against it, fighting the spin with raw friction. This is the moment the push from your foot finally reaches the road through the tire. Friction does something strange and simple. It takes the motion of the car and turns it into heat. The energy of all that speed cannot simply vanish, so the pads and rotor convert it, growing hot enough to glow on a hard stop. The wheel slows because its energy is bleeding away as warmth into the air. Your car does not really lose its motion. It trades that motion for heat, and that quiet trade is what stops you. You might wonder why engineers trust a liquid for something so important. Air would fail, air squeezes, press a sealed syringe of it, and the plunger sinks while nothing happens at the far end. That sponginess would swallow your push. Liquid refuses to shrink, so every bit of force passes straight through. That is also why a single air bubble in the line feels dangerous. The bubble compresses, the pedal goes soft, and the message never fully arrives. So follow the whole path. Your foot presses the pedal, a lever that magnifies the force. The lever drives a piston into the master cylinder, squeezing sealed brake fluid. The pressure races through the lines to all four wheels. There, a wider piston multiplies the force again, the caliper clamps, and the pads bite the spinning rotor. Friction drags the wheel to a halt and turns the motion into heat. One gentle push, multiplied and delivered, stops a ton of steel. A soft pedal, a sealed liquid, and a clever trade of force for distance. That is all it takes to tame a moving car. Next time you come to a stop, feel the calm certainty under your foot, and remember the quiet chain working faithfully beneath it.